signal can be compared to behavior subject. That is also very similar structure, although the use cases of those two are completely different. It's very cool because the computed signal values are memoized. That means the business logic isn't recalculated every time the value is accessed. The signal allows us to perform less operations. This feature is called signal-based components. Signal-based components will introduce isolated change detection system to the Angular. Hey everyone, welcome to our Angular Meetup. Today we are going to discuss the bright future of Angular signals. After this lecture, you should know what are the signals, what are their benefits, and the most important one, how they are going to impact our daily tasks. I'm David, and I am an Angular developer at House of Angular, a place where we inspire other developers and create the best solutions on the market. Without further ado, let's go to the signals, or shall we? In my opinion, before we talk about the signals themselves, we should cover topics such as change detection, component rendering, and a library that powers up current Angular change detection system that is called ZoneJS. The ZoneJS is a very great tool that allows us to completely forget about the process of rendering changes in the UI. It happens like this because the ZoneJS informs Angular every time an event has finished in the browser. Thanks to that, Angular executes then change detection cycles and updates our UI. That whole thing gives us that automatic rendering feeling that allows us to forget about the process of rendering at all. Unfortunately, all of this stuff comes at a pretty quite big price. This price is distributed between the different sectors. First one of them is that the ZoneJS slows down the initial runtime of our applications. Before any Angular code can be run in the browser, we must firstly load and run the ZoneJS properly. Then, the ZoneJS slightly impacts our bundle size. It wouldn't happen if you wouldn't need it in the first place. And the whole problem with the ZoneJS is its informing behavior. It only tells Angular when to detect changes, not where to update the components. As a result of that, we are restricted with the change detection system, and often we may get into situations where we have performance issues with it. Fortunately or unfortunately, of course, we can use that duct tape and fix those issues. But the question is whether we should do this. We can, of course, patch that polyfills config and disable some events so they don't inform Angular about the made changes. We can handle these changes manually and update the components in a way that works differently and is more performance friendly. Though it's still just simply patching. In my opinion, that's not a real solution, and we should go deeply into the problem of the change detection itself. So let's start and talk about the change detection. The first thing that comes to my mind when talking about the change detection is the default change detection strategy. It updates the UI every time we click into an input, we click a button, we type something into an input, or simply get that response from the HTTP requests. After this happens, every component in our tree is updated. And as you can see on that GIF, it's quite performance heavy because we update 7 components, maybe 10, 100, or even 1000. That's quite a powerful operation that requires a lot of time. Fortunately, we have this thing that we should always use in our components that is called on-push change detection strategy. It only updates a small part of the component tree that has actually changed. Because of that, we are able to create applications for large enterprises that simply work and work very great. They don't have any lag or issues with the performance. It works in a way that we render the component again only if its data has changed since the last change detection cycle. It may be a new value in the input or triggered output. Unfortunately, the performance gain that on-push change detection strategy gives us is not always enough. Sometimes we may actually get rid of that zone, so we get even more greater applications that simply have that flow diagrams or anything like it. In these cases, we may want to use the RxAngular. RxAngular is a library that introduces isolated change detection system to our framework, and thanks to that, we are able to update just single component in our tree. We no longer have to depend on that from top to the bottom change detection strategy that updates the UI in a way that is not the best performance friendly. Okay, so as we've covered the basics of change detection and component rendering, I think we are ready to talk about the signals. So what is a signal? A signal is a container for a value that changes over time. Thanks to signal, we can react to those value changes, and it works similarly to the observables because those two structures are built on the top of the subscriber-publisher pattern that, in my opinion, the signal can be compared to behavior subject. It is also a very similar structure, although the use cases of those two are completely different. So, as we know the theory behind the signals, we can go to the API itself. To create a signal, we use the signal function that takes two parameters. The first one of them is the initial value of a signal, and the second one are the options. To read a value of the signal, we use the signal value reference. In this case, the number signals variable, and we make argumentless function call on it. As you can see, reading a value of a signal is pretty simple. We can modify the value of a signal by using one of the three methods that were created by the Angular team. We can take advantage of the set method, update, or mutate method. Each of them has unique powers and will be used in different situations. Let's start talking about the modifying value from the set method. It allows us to override the current value of the signal. As you can see on the example on the left side, we are able to implement such functionalities with it as reset counter odds or set counter value. It also works with the objects, as you can see on the right side, where we are resetting the array of users by simply creating a new array and setting it to the signal value. In cases where we would like to have access to the previous value while setting the new one, we can take advantage of the update method. As you can see on the left side, this method takes one parameter, and this parameter is a function that's first argument is the previous value of the signal, and that function should return a new value of the signal. It works pretty simple and it's very good when you use it with the immutable data approach. As you can see on the right side, where we are creating the shallow copy of the user's array and we are adding a new user to it. It's very great, but in cases where we would like to use the immutable approach, we can take advantage of the next method, that is the mutate method. This method exposes to us current reference to an object or array. Then, thanks to that exposed reference, we are able to modify it by using its methods or accessing the values at the particular indexes. As you can see on the left side, we are taking advantage of the array push method and we are adding new user to an existing signal value. Or, as you can see on the right side, we are accessing the user at a particular index and we are setting a new user to it. Unfortunately, this method has one big con, and it is that Angular checks whether the value of a signal has changed by using the free equal JavaScript operator. And because of that, it only compares the references, not the actual values of the objects and arrays. As a result of that, sometimes we may get into a situation where our computed signal is not updating, or simply the UI is not updating too. That's why I would stick to the set and update method that, in my opinion, work with the immutable approach much better. Okay, so as we are done with the basic concepts of creating, reading, and modifying a value of a signal, we can go to the next topic and talk about what we can build with the signals. there's this special type of a signal called computed signal. The computed signals are a perfect way to create signals from other signals. I would like to compare them to the getters that we are currently having in our Angular classes. As you can see on the right side, this example is pretty simple. We are declaring first name, last name, and in the getter, we're using the concatenation so we can get the full name. In cases of computed signals, it works very similarly. Firstly, we're creating the first name signal, then the last name signal, and finally, we're using the computed function that takes as a parameter a function that is a factory for our new value. This full name variable will be updated every time one of the dependent signal changes. So it's very cool and good way to have that computed properties that simply works and update in real time. I've created another example with the computed signals to visualize to you one more concept that is, in my opinion, very good about the computed signals that we couldn't previously achieve with the getter. It's the memoization. It's very cool because the computed signal values are memoized. That means the business logic isn't recalculated every time the value is accessed. Thanks to that feature, we can execute such operations as filtering or sorting without any performance concerns. So, as we know what memoization is, we can go into this example and look at it. I've divided this code into 3 pieces: the signal setup, utility function, and logic. Let's start with the signal setup. We are declaring a signal that will hold our users. Initially, we declare 2 users, Joe and Mark. Those users are not anonymous. Below that signal, we create another signal that is derived from the original user's signal, and it filters out the users that are not anonymous. In the utility function section, we are creating addUsers function that allows us to add a new user to that original user's signal by using the immutable approach. As we are done with the setup and utility, we can finally go to our business logic. In that case, we are firstly printing out the length of the admin users array. And as we could have expected, it's equal to 0 because initially we haven't declared any admin user. Then we are using our utility function to add a chain that is an admin to original users array. And as you can see below, after we print out the admin user's length, it's equal to 1. That means the computed signal value have been automatically updated, and we didn't have to do anything to achieve this perfect and great result. So, as we know how the computed signals work, let's talk about one more topic, the subscription thing in the world of the signals. The signal effect function works very similarly to the subscribe function of the observables. Although it has few differences, it also allows us to execute code every time a value of a signal changes. The effect can be declared seamlessly in the injection context that is present in the constructor or in the property initialization. It's a very cool way to react to value changes because we no longer have to unsubscribe or use those cool operators like take until destroy that takes many words in our line of the code. I've prepared one more example that is a little bit more complex, and I would like to show you the difference between the behavior subject and signal effects. Here, the code block on the left side and on the right side is built with the same reasoning behind it. The business logic is exactly the same, though we use 2 different structures that are completely different. On the left side, we are using the behavior subject for storing our value, where on the right side, we are taking advantage of the signal. So let's start explaining this code. Firstly, we are declaring our container name. Then in the constructor, we are reacting to our container value changes by using the subscribe function on the left side and the effect function on the right side. Every time a value of our name changes, we display to the console the updated name, so we can see what actually has happened to it. Then, in the eighth line, we're setting the value of the name to Julian, and after 1 second, by using the setTimeout function, we set the value following to Mark and then to James. As you can see, the code outputs of those two structures are completely different. It's because the signal effects are executed at the end of the change detection in comparison to observable subscription, where the code is executed every time a value changes. Thanks to that cool features, the signal allows us to perform less operations. That, in my opinion, is a very performance-friendly solution. Although it has few differences, as you can see, to the subscriptions that should be used in different situations. Okay, so as we went through this example, let's talk about the use cases of the signal effects. And as you can imagine, they are pretty useful. Firstly, as you could have seen multiple in this presentation, we can use them to log messages to the console in the process of debugging. Then we can send API requests every time a value of a signal changes. They will be also useful in the process of synchronizing data from the memory with the data that is present in the local storage. We can execute DOM operations and perform custom rendering, for example, in the charts libraries. So, as we've covered the Signals API, I think that we are ready to talk about the next topic, whether the Angular signals are going to kill RxJS. In my opinion, it won't happen anytime soon. It's like this, because the Angular signals solve completely different problem than the RxJS. You could have seen it on the comparison of the behavior subject and signals and reacting to their value changes. As you could have seen, the behavior subject allowed us to react to every value change, where the Angular signals effect allows us to react to only a few value changes, particularly the last value that was changed in that JavaScript event loop tick. Another thing why the Angular signals won't kill RxJS is that because the RxJS introduces multiple operators that are pretty useful and allows us to save a bunch of the code. Examples of such operators are primarily the throttle time operators, for example, the debounce time. Another thing why Angular signals won't kill RxJS, in my opinion, is that the Angular team introduces to us the conversion utilities. The two functions called toObservable and toSignal allows us to convert a signal to an observable and the other way around. Thanks to those utilities, we are able to connect those two different worlds together and work in them continuously. As you can see on the left side, the toObservable function is pretty simple. We simply call it on the signal, and then we are left with the observable. We can subscribe to it, and as you can see on the code block on the left, below, the example output would print out the new value of the observable whenever we set a new value of the signal. It also works in the right side, where we take advantage of the toSignal method to convert our observable that comes from API to a signal. Then we can take advantage of that signal and use it in the component synchronously, or call it in the template and read its value without using the impure async pipe that also slightly impacts our performance. I've created an example application to show you how we can connect those two words together and how they will look in the new Angular feature called Angular signal-based components. This new generation applications fetches posts from an API and displays loading text, as you can see in a while. Whenever we fetch the data, it's like this. Then, whenever we fetch a non-existing post, we display post not found text to the user. So without further ado, let's create our application. We'll start by creating data model. Here, we are declaring post interface that have ID, user ID, body, and a title. Then, in our newly created post service, we inject the HTTP client and create getPost method that takes an ID of a post that we want to fetch. We are returning in it the HTTP GET response from the JSON placeholder API that has posts. And we are delaying that response by 500 milliseconds so we can see the loading text actually appearing in the UI. As we've created the service and handled the API communication, I think that we are ready to create a component itself. Firstly, we are injecting that post service in the component in the second line. Then we're creating two signals that will be primarily used to store the data in our component. Those signals are one, selected post ID that will store selected post ID, and is loading post that will indicate whether the loading text should be shown to the user. Below that, we are taking advantage of the toObservable function in the eighth line, and we are converting selected post ID to observable so we can pipe it and react to its changes. First thing that we do after it changes is that we are setting the isLoadingPost signal to true, so the loading text can be actually displayed in the UI. Then we are making an HTTP call, and we are getting the post. In case the API returns an error, we are setting the value of that stream to null. After the API communication is finished, we are setting the loading signal again to false, so the loading text can disappear. The last thing that we do in this component is that we are handling the selected post changes of the select. Simply, we're setting a new value of the signal selected post ID to a new value of selected post. As we went through the component, I think we can go to the template. I've divided it to 4 sections. The first one of them contains a select that allows us to select post ID. Then we have our primary container that checks whether the post is loading or whether the data is actually a trophy data. In these cases, we will display the post data to the user. Let's explore this code block on the 7th line. Firstly, we're checking whether the value of isLoadingPost signal is true. In case it is, we display the loading template to the user that can be seen in the 14th line. In case we are not loading any posts at this particular moment, we are going deep down in the condition tree. In the 8th line, we're checking whether the post data is trophy. In case it is, we display the post title and post body to the user. In case the data is not trophy, that means it's null because the server returned an error response, we display non-existing post to the user. And as a result of that, you should have seen this application that simply works and connects the 2 different words of RxJS and Angular signals together. As you could have seen, we've just created an application that connects 2 different words together, the word of the RxJS and the word of Angular signals. Thanks to that, in the future, we'll be able to use the new feature that will probably be released in the Angular 18th. This feature is called signal-based components. Signal-based components will introduce isolated change detection system to the Angular. Thanks to that, we will be able to drop out the zone of our applications and get that extra performance grasp. Thanks to that we no longer have to check through all of the components in the tree and check whether they have been changed since the last change detection cycle. In my opinion, this feature is one of the best features that is coming to Angular in the last few years. It's so revolutionary, and thanks to the signal, we're able to get that extreme performance gain. The signal-based components are pretty useful. And before going to the next sections and saying that signal components are very good, I would like to one more time go back to the ngConf 2022. At this conf, the Angular team was just starting to working on the signals and were brainstorming about the new solutions for underlying change detection system in Angular. Back then, they knew that something with the change detection was not okay, and even though the ZoneJS is a great tool, it hasn't aged very well. Firstly, they asked themselves a question whether they can make Angular zoneless, and thanks to these signal-based components, we can make and will be able to make Angular zoneless applications without sacrificing developer experience that we are currently have to sacrifice in case to create zoneless applications. Then, thanks to signal-based components, we'll have that per component change detection, and the signals themselves allow us to create stores for state management. This simple container for a value gives us so much opportunities to handle the data. The last thing that they were brainstorming about and they shared with us is that they wanted to introduce computed properties to Angular. And as you could have seen, we are now able to create computed signals in the Angular 16 by using the computed function. Last thing that I would like to look at this slide is that big rock that, in my opinion, symbolizes the current change detection in Angular, that even though it's not pretty slow, yet still it can be improved, and it can be improved very, very well. So I would like to show you once more the comparison of those approaches. Firstly, on the top, we have both built-in to Angular 2 approaches that take advantage of the default change detection and ZoneJS. We have the default change detection, as you can see on the left side, that every time an event is executed, we'll execute rendering task on all of the components in the tree. As you can see now, it updates 7 of 7 components. It's quite a lot. In cases where we improve this by taking advantage of the on-push change detection strategy, we update only 3 of those 7 components. If you would like to have perfect performance applications at this point, we will use a tool that allows us to create zoneless applications seamlessly. For example, the RxAngular that also have that isolated change detection system and no longer updates our component using the hierarchical tree. It simply updates our component every time a value in it has been changed. And in the future, we'll have these signal-based components that also have that isolated change detection system that simply work, and it will work very well. It's so important that I would like to show you on the next slide a little bigger scale. Here we have 7 components, but what if you would have 70 of them? That's quite a lot, and it isn't the maximum amount of the components that we can have. Imagine that some applications may have hundreds or even thousands of the components. In these cases, going from the top to the bottom of the tree and rendering all components again is a very performance-heavy task, and it must be avoided at all costs. In my opinion, that's why the Angular signals are one of the most important features in the last few years of Angular development. So, as it's so important, let's talk about their bright future, and I would say they will have an amazing future in the next few years of the Angular. As you can see, currently we are in developer preview as the Angular 16, and the signals shouldn't be used in the production because they may change, even though sometimes we can take advantage of them, especially as a data storage unit in our applications. In the future, we may, of course, expect stable version of the Angular signals, and it will be probably introduced around the Angular 17, 18, or 19. With that, we'll probably get the signal-based components that will revolutionize the way in which we detect changes in our components. On the top of these signal-based components, probably there will be created many UI libraries. Who knows? Maybe even the Angular material will move to the component-based, to the signal-based components itself. The signals also allow us to have a new way to handle storage in our applications. Currently, the NGRX team is working on the signal store, a new library that allows us to handle the signals in our applications. The NGRX team also allowed us to take the signals instead of observables from the current NGRX store. In my opinion, that's very useful and allows us to integrate with the signals at this point. We no longer have to wait and create our own solutions to introduce it. The last thing that I would hope that Angular introduces someday is the granular rendering. It's a special technique that renders the UI only once, and then updates only small chunks of it that uses the signals. Imagine that we could have just updated simply 4 or 5 lines of the template that has 200 lines. That's a huge performance gain, and this approach is used in the Solid.js that is known to be one of the most performance-friendly frameworks that is currently on the market. Unfortunately, this presentation comes to an end. In my opinion, it's very hard to cover that comprehensive topic of the signals in just around 20 to 30 minutes. This one is pretty complex and have many mysteries. For example, the untracked function and how this stuff works on the bottom. We've explained some of it in our first article, Angular Signals, a new feature in Angular 16. We've also created another article, so you will no longer think that the Angular signals will kill the RxJS in Angular. This article is titled, Why Angular Signals Won't Replace RxJS. Here, we give a few other reasons why this won't happen anytime soon. Though, still, we should keep in mind that it may happen someday, but it won't probably happen in the next 2 years. So, this is the end of the presentations. I hope you like it. Feel free to share your opinion about the signals in the comments, read our blog posts, and simply have fun with the Angular.